In this video, I'm going to talk about data transformation. Here we have a nonlinear relationship between x and y values, and we want to change it to a linear form by applying the log x transformation. So first of all, we have to take the log of all x values equals to log of this value and close the bracket and press enter. And then I drag this down to find the log of the rest of x values. From now on, we work with these values, log x values, and denote them with capital X. Now, there is a linear relationship between capital X and y values, and we want to use the linear regression to find the equation of this line. Okay, so first of all, we have to find the mean of capital X values. So we need the total of x values. I click on AutoSum to find it. And we need the number of x values, count of these cells, capital X values. Now ready to calculate the mean of x values, which equals to total of x values divided by number of them. Then we can calculate the mean of y values. So we need the total of y values, press enter, and this equals to total of y values divided by number of y values. Now in order to calculate the standard deviation of x, we need to calculate x minus x bar squared. Just be careful, we just work with capital X values. X value minus x bar to the power of 2. But here, the cell which includes the mean of x values should be an absolute cell. So we put $L, $1 to have an absolute cell. Now, ready to drag this down and apply it to the rest of the cells. And then we need the total of them in order to calculate the standard deviation. Now, standard deviation is the square root, SQRT, of this total divided by number of values minus 1. And then press enter. So standard deviation of x is 0.10. Now for calculating the standard deviation of y, similarly we need to calculate y values minus mean of y values to the power of 2, and then we have to fix the address of the cell which includes the mean of y values. In order to have an absolute cell, we put $, before and after letter L. Now ready to drag this down. We drag it down to apply to the rest of the cells and click on AutoSum to have the total. And the standard deviation of y is the square root, SQRT, of this total divided by n minus 1. N minus 1. Now we need to calculate the correlation coefficient before calculating the slope. Correlation coefficient is the total of x minus x bar, y minus y bar divided by n minus 1, standard deviation of x, the standard deviation of y. So we need to calculate x minus x bar. Just work with capital X, be careful, minus x bar times y minus y bar, but we have to fix the address of the cell which includes the mean of x values, put it in dollars, and same for the mean of y values. Now ready to drag this down and apply it to the rest of the cells. And this total is important to us to calculate correlation coefficient. So correlation coefficient equals to this value sigma of x minus x bar, y minus y bar, divided by n minus 1 minus 1 times standard deviation of x, standard deviation of y, standard deviation of y times standard deviation of x, and close the bracket and press enter. So the correlation coefficient here is negative 0.95. Now we have all the values which are needed to calculate the slope. Slope is correlation coefficient times standard deviation of y divided by standard deviation of x. Then press enter. So the slope is negative 1175.83. Now we can calculate the y-intercept, which equals to y bar minus b, which is the slope, times x bar. Just work with capital X. Now we can write the equation of the line. So here y equals to a 2263.25 plus bx, but here slope is negative 1175.83 capital X, right? Now we substitute the log x here. Capital X is nothing but log x. So the equation here is y equals to 2263.25 minus 1175.83 log little x. Now this formula helps us to predict y values by having x values.